In early April 2026, NASA launched Artemis 2, marking the first time in over 50 years that humans traveled beyond low Earth orbit. The mission was conducted by NASA as the first crewed test flight of its modern lunar exploration system, using the Space Launch System rocket and the Orion spacecraft to send astronauts on a journey around the moon. Unlike Apollo missions, Artemis 2 was not designed to land on the lunar surface, but instead to test whether humans and spacecraft systems could operate safely in deep space and return to Earth under real mission conditions. After launch, the spacecraft left Earth orbit and entered a translunar trajectory, carrying its crew into a region of space where Earth's protective magnetic field no longer provided significant shielding from radiation. As the spacecraft traveled outward, the crew experienced sustained microgravity, exposure to deep space radiation, and the operational reality of long communication delays with mission control on Earth. The mission followed a free return trajectory around the moon, using lunar gravity to bend its path naturally back towards Earth without requiring major propulsion maneuvers, which demonstrated a critical safety architecture for future deep space missions. As the spacecraft passed behind the moon, communications were temporarily interrupted, and the crew had to rely entirely on onboard systems and pre-programmed autonomy during the far side phase of this flight. During the lunar flyby, astronauts viewed the moon from close range, experiencing a perspective no human had ever seen since the Apollo era, while onboard instruments continuously recorded navigation, radiation, and system performance data. Throughout the mission, the spacecraft's life support systems maintained a stable cabin environment, confirming that long-duration human survival in deep space is pretty feasible with our current engineering approaches. And after completing its lunar loop, Artemis 2 successfully returned to Earth, where the crew re-entered the atmosphere at extreme velocity, testing the Orion heat shield under real lunar return conditions. The spacecraft experienced intense heating during re-entry, but the thermal protection system performed within acceptable safety limits, which provided valuable data for future crewed lunar landings. Upon landing, the astronauts underwent physiological recovery as their bodies readjusted to Earth's gravity after spending days in microgravity beyond Earth orbit. The mission demonstrated that while human spaceflight beyond Earth is possible, the human body still experiences a lot of stress and adaptation challenges that has to be addressed for longer missions to the Moon and Mars. Artemis 2 therefore confirmed that the core architecture of deep space exploration is functional, including launch systems, spacecraft systems, navigation, radiation protection, and Q survival in cislunar space. But at the same time, it revealed that deep space travel is not simply an extension of low Earth orbit operations, but a fundamentally more demanding environment that requires higher levels of autonomy, resilience, and biomedical preparation. The success of Artemis 2 represents a transition point in human space exploration, where travel beyond Earth orbit has shifted from experimental and now it's operational. It establishes a foundation for future missions that will aim to land astronauts on the moon and eventually support sustained human presence beyond Earth. This is really cool. If you guys enjoyed this video, make sure to like and subscribe. Be curious like a child, the world needs more of it. Bye!